Okay, last question. Already done number 6. I'm finishing off this 2024 Unit 1 Pure Maths paper. My students. Number 5. And then I'll go. Question says, number 5 says, we are to give us this function. It has 3 parts, right? 3 sections of that function. There's a part of it for when x is less than -1, -2, sorry. The -10 when x is equal to -2. So the f of -2 is fine here. And then when x is greater than -2, it becomes that function. So I guess -2 is a critical value on this function. First part wants us to determine f of -2. That's right here. It is just equal to 10. -2 is simply equal to -10 right here. That is defined. 1 mark for that. Next part says, find the limit as x tends to 2. So to do this, I'm going to check it and do it from the left and do it from the right. Right? Limit from the left, limit from the right. So that's what I'm going to do for this to make sure that it exists and has a value and stuff. So let's do it. So the limit as x tends to -2, I'm going to do from the left first. Means that my function, when I'm on the left of 2, I'm on a value less than 2. I'm on this function. So I'm going to write that x plus 4 cubed. I am on x plus 4 cubed when I am on the left side of -2. So that becomes 8. Right? That becomes 8. I'm putting a minus on the 2 here. I'm on the left side of -2. So I put -2 in there. Let's just show some room. -2 plus 4 cubed. This becomes 2. 2 cubed is 8. Then on the right, if you don't get the same value, the limit does not exist. So the limit from the right, the limit as x approaches -2 from the right, at -2, I am on the function that's on the right side of -2. That's this one. I'm on this function. X squared plus 8, x minus 1. X squared plus 8x minus 1. What is that equal to? That becomes equal to -2 squared. -2 squared plus 8 times -2 minus 1. Problems. This becomes 4 minus 16 minus 1. That becomes -13. Right? -13. That's 4 minus 17. 4 minus 1 is 3. So the limit does not exist. But a question set up. The limit does not exist. This means the limit from both sides. So we're going to say therefore, the limit from both sides does not exist. I get a different value from the left as you got from the right. So therefore, the limit as x approaches 2, which is -2 of f of x, does not exist. That's it. The limit from the right is different from the limit from the left. This means the limit from both sides does not exist. All right, good. Next question. It says, hence or otherwise determine if f is continuous. Nope. Anything that goes wrong at x equals 2, it is not continuous. I'm going to write the conditions. So let's write it. For f of x to be continuous at x equal -2, what must happen? The limit as x approaches -2 of f of x has to be equal to f of -2 and both must be defined, that must exist. So this must be defined, must exist. This must be defined, must exist, and they must be equal. This does not exist for multiple reasons. The limit from the left and the right not even equal to the f of, because the f of -2 is -2. Everything gone haywire. F of -2 is -10, it's not even equal to any of these. And these are also not equal. Everything out of sync. Right? So we don't have this. Right? So we don't have this. So we have stated the condition for it. We don't have that. Right? Because they're not equal. So we can draw the conclusion. So therefore, f of x is not continuous. You have to say at x equal -2 to specify the point we're testing continuity. To specify this. All right, because it might be continuous elsewhere, just not continuous at this point. You cannot just say it's not continuous, done. No, you have to specify the point. All right, this one, I want us to evaluate that limit. So for this one, we're going to use the rule or the identity or whatever that the limit as x approaches 0 of sine of some function of x over the same function of x is equal to 1. Is equal to 1. Equal to 1. That's what we're using. All right. Whatever function of x is there, same thing must be there. All right. So we're going to have to split up this guy. Split up that guy. We're trying to create this situation for these. Right? So a little bit of jugglings here. So this becomes equal to the limit as theta we're using tends to 0. All right. So what I'm going to do, I'm going to divide this by theta and divide that by theta. All right. Space out. Space out. Shift it over a little bit. I'll put it here. It's going to be equal to, right? Bracket. I'm going to divide the numerator by theta and divide the denominator by theta. It's going to become sine of theta over theta over, and then this now becomes sine of 4 theta initially over theta. What I've done so far is I've divided the numerator and the denominator by theta. But if I have 4 theta here, I need a 4 theta here. So I'm gonna have to go and multiply under here by a 4, and then multiply back here with that same 4 and leave it as that. That's what I'm going to do. And so this resembles this function, or that setup. This in the bracket also resembles that setup. 4 theta, 4 theta, theta, theta. When I apply the limit, this is going to be 1 and this is going to be 1. When I apply the limit, so I'm applying the limit now. So this is going to become equal. This becomes 1 divided by this 4. and this becomes 1. And the answer is simply a quarter. Quarter is the answer right there. And it's answer. Nice and easy 4 marks. I mean, paper wasn't hard at all. I mean, not all the questions. Some of the questions were challenging, time consuming, and things. Such is life. Next question. I will have to do the same paper. This question says, function g is defined as this. It's a function g. It's a cubic. All right. There's no constant and it passes through the origin, as you can see. You can factorize it right here now and factorize this into x squared bracket x minus 3. This x squared right here means that it has a turning point on the origin. That's what this x means. Repeated roots of x equals 0, and then you have this root, x equals 3. So it's a repeat root on the x-axis, and wherever you have a repeat root on the x-axis, you have a turning point there. All right, so that's what's going to happen in this question. Look at the function, you see that. It's also going to have the shape, because the cube term is positive. It's going to have that shape. All right, let's go. Question says, determine the stationary points of G and the nature. So because it stays this way, the one with the smaller x value is going to correspond to the maximum. When the larger x value is going to correspond to the minimum. That's the x value at the stationary points. Let's proceed. So at the stationary points, the gradient function, which is g prime of x, is equal to 0. That's when I differentiate, I put equals 0. So when I differentiate this, that's a cube, and it's a cube, it's a cube, it's a square. Right, so when I differentiate that, I'm going to put that out here. When I differentiate that, I'm going to get 3x squared minus 3x squared minus 6x equals 0 at the stationary points. I'm also going to need the nature, so it kind of makes sense to get the second derivative. This is the first derivative. Let's get the second derivative here. All right, so I'm just write it in red what it is. Maybe I'll just write it when the time comes. So this is the first derivative. T equals 0, so I'm going to factor that 3x out of it. And I'm going to get x minus 2 equals 0. So you see I'm getting x equals 0. See, x equals 0. That's a stationary point at x equals 0. That's on the x-axis. No, not yet. X equals 0. That's here on the y-axis, where the y-axis is. And at x equals 2. All right, so those are 2 places. But I must find the points. So to find the points, I have to substitute them back in the function. So substitute this 0 in the function. I'm going to get 0 here, so it's at origin. So I'm going to say and the y equals 0 for this one. We substitute it back in there. And for this one, the y equals substitute 2 inside there. I'm going to get 2 cubed minus 6 times 2 squared. What is this equal to? Let me shift this over. Shift this all over. What is this equal to? This is 8 minus 24. 8 minus 24 is negative 16. Negative 16. So this is negative 16. Negative 16. So those are stationary points. 0, 0, and 2, negative 16. This one is the maximum. This one is the minimum. And I do a smaller value. But I want us to tell them. So stationary points are 0, 0. Stationary point on x-axis. And 2, negative 16 are my stationary points. this one is going to be the max, and this one is going to be the mean one, because I said the graph shape like this. The max will correspond to the lower x value comes first, right? But let's say they know that. More things you know, the better. All right, let's go. So I need the nature now. So I need the nature. I have to calculate and show or get the nature. Kind of say it as I've been saying it. So I have to get d2y by dx squared, which is equal to, remember, this is my dy by dx. There's going to be 6x minus 6, 6x minus 6. So you can see it right away at x equals 0. Or we can say at 0, 0. We know the point is 0, 0, x equals 0. So at 0, 0, the d2y by dx squared is negative 6. Is negative 6, which is less than 0, which makes it a maximum. I'm going to see it afterwards. And at the point 2, negative 16, the d2y by dx squared. Well, I'm using dy by dx because that gave me g. It don't really matter. It don't matter. And come back up here and say, let y equals g of x. Right? Since I'm using dy by dx, it really matters then. This is going to become equal to, I'm going to plug the 2 in there. So I'm going to get 6 times 2 minus 6. That is 6, which is greater than 0. This one means that we have a max, therefore max. And this one greater than 0. That we have a min. You can draw the conclusion and say, therefore, 0, 0 is maximum point, and 2, negative 16 is minimum point. These are stationary points. One maximum, one. That's the nature. That's the nature. And I've answered the question of the nature. So I put a question sign on it. What is the nature? Question mark. What is the nature of those stationary points? That's what we're doing down here. Determining the nature. All right. 9 marks for doing that, all of that. Now, continue here. It says, hence or otherwise, sketch a graph of G showing its intercepts, stationary points, and any other important feature. All right, so let's look at the scale of this graph. So scale don't look friendly already. But the minimum point is way down on negative 16. So we'll fit negative 16 on this. Let me put the x-axis down here. So. All right, so we know we need to have a stationary point on the x-axis, and the maximum at origin right here. And then to have a minimum point at 2, negative 16. 2, negative 16. So we're going to kind of scale up the graph on kind of way, you know. Put the x-axis right here, someone. Put the x-axis further up. All right, I can move the x-axis and do a one x-axis, but leave it. All right, so negative 16. It's got 2, 4, 6, 8, 10. Can't reach. All right, 4, 8, 12, 16. All right, negative 4, negative 8, negative 12, negative 16. Unless I calculate that minimum point wrong, I think I'm going to check it again. Minimum value of negative 16. I'm going to double check it. Double check this one. So here, differentiate this. Just double check it. I get 3x squared minus 6x equals 0. Take out 3x, get x minus 2 equals 0. Then I take the 2, let's put it in this one here. Yes, here I'm going to get 4, 2 minus 3. No, no, it's not. No, I got a mistake then. It's negative 4. 2 into that. 4, so what did I do? Did I do the first one? So this is 8. And this is... No, I said a mistake. No, put a 6 right here. Okay. All right. See, you have to be able to catch yourself, guys. Something don't make any sense. So I put out 6 right here. It should have been a 3. Okay. Happen for the best of us. It's a negative 4. Right? It's 8 minus this is 12. Negative 4. So this is a negative 4. Right? And so this is a negative 4. That is it. Take it out of this video. Take out the wrong parts. And then this is a negative 4. So then me just get to out and find out, you know. Now it can work. All right. Negative 4. So negative 1, negative 2, negative 3, negative 4. 1, 2. 1, 2. All right. So we know that it turns here. It also passes through the origin. Stratum do. So it turns here to the origin maximum and then turn minimum down here. Where does it cross the y? The x-axis? We can find out where to cut the x-axis instead of 1. Cut the x-axis at 3 based on that. All right, with the x-axis at 3. So we can squeeze it in there, but I said I want all those other features and axes and what have you. So this is the function cross x-axis at 3. Put that one up here in red. On the x-axis is 0, 0, and 3 is 0, because the y equals 0 on the x-axis. So this is going to give me 3, 0. So pass through 3 on the x-axis. We can make the horizontal scale a little bit wider. And you can make the horizontal scale a little bit wider. All right, so let's put it out a bit. So when this be 1, this be 2, this be 3. All right. And yeah, so here's gonna be our minimum point now. 2, negative 4 right here. It passed 2, 3. Pass 2, 3, you know. Pass 2, 3 up here, so pass 2, 3. It turns at a maximum here, as we said. The pass 2, 3, so go like this. This 3 pass to make sure. Pass 3. Like this. On the tablet. The sketch. Like that. And then it go like that. So that's sketching. So I'm just gonna put on those few points on it. What about the rest of it? Alright, this I'm gonna show it across the x-axis, y-axis, turning points. Putting on anything else. Draw that go up, so I'm not putting on anything else. Alright, and let's say inside I sketch a graph showing its intercepts. Same here for 3. And it is 3, 0. One intercept. The 0, 0 is maximum turning point. Maximum turning point 0, 0. Minimum 2, negative 4. Minimum turning point 2, negative 4. Negative point. Minimum turning point. That is a sketch. Yeah. Yes, another feature, station points. Another feature. I have another important feature. That is it. I don't know of any other important feature. That is it. That finishes this question. Yep. I was looking to see if there's anything else I want to add to this. Can't think of anything else. With the turning point of the cross x-axis. That's the origin. That is it. Paper done. The paper is done in. It's done, 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 done. All right, guys. That's it. I'm just going to record one more video, which I'm just scrolling through the pages to set up on the playlist that I'm going to have. See all the questions are now done. I'm going to just do a playlist with just that. Do a video. Scrolling through, stopping on each page. For those who want to have a quick look at the solution. Right. That is it. Paper done. We start at once, right?